So let's look at a simple example of the nearest neighbor classifier using the Euclidean distance. So our data set are 28 by 28 images of handwritten digits. So what we do is we treat this image as a vector in R784, because that's how many pixels are in this image. And here are examples of what the data looks like that we're dealing with for each of 10 possible digits. So this is one input, here's another, and so on. And then with each of these data, with each of these observations in our training set, we'll have a label. So we'll have an observation that says this is an instance of a 0, and this is an instance of a 7. And we'll have many of these labeled examples of all of the digits. So for example, in this problem, we have 60,000 labeled data points, meaning we have 60,000 different instances of a particular digit and the corresponding label of which digit it is. And we'll also have a testing set of 10,000 handwritten digits. And these are 10,000 new images that we don't know the label for. So for the nearest neighbor classifier, first let's think of the training error. It's a bit vacuous, but it's good to think of what that actually means. So if we wanted to predict the label of one of our labeled data points, so if we have a labeled 0 and we want to see according to our nearest neighbor classifier, how well would we predict that label? The answer is we would predict it perfectly, because any point in our training set is closest to itself, and therefore it would pick its own label. So the training error in the nearest neighbor classifier is always 0. We can predict an observation's own label perfectly, always. However, if we looked at the testing data, we can notice that we don't do perfectly, because for an unlabeled data point, we can only pick one of the labeled data points to assign in order to assign it a label. And so we do have some error. However, we see that it's very small for this problem. So using the L2 distance and the nearest neighbor classifier, we see that the error rate, the probability, the fraction of these 10,000 training points that we got wrong by simply assigning the label to be the label of the closest labeled point is 0.03. 97% of the time, we get it right by just pairing an unlabeled handwritten digit with the closest labeled handwritten digit, and then assigning the label of the unknown digit to be the label of the closest digit. So let's look at some examples. For example, here are four different examples of what we get wrong. So for example, this is an input 2. We don't know it's a 2, so we find the handwritten digit in our training set that's the closest to it in the Euclidean sense, and this is what it returns, and this is labeled as an 8. Therefore, we would say this is an 8, so we got it wrong. Similarly, this input 3 is closest to this labeled 5. Therefore, we assign the label 5 to the input 3, and we get it wrong. So these are some examples of what we end up getting wrong. So one observation, and this is for this particular data set, is that if instead of picking the closest labeled training point and assigning the label based on the nearest neighbor, what if we looked, for example, at the 3 closest neighbors? So for this test point of a 2, if we look at the 3 closest neighbors, the closest is this 8 from the original nearest neighbor problem, but the next 2 closest are 2s as well. So if we looked at the 3 closest neighbors and then assigned the label based on a vote, in that case we would have gotten this 2 right, because 2 of the training sets would have voted to label this a 2, and 1 would have voted to label it an 8.